So we're recording again, y'all. Today, what I'm going to do, I'm going to go over section 6.2. So let me go ahead and get started. I have my notes right here. Okay, 6.2. So chapter 6, y'all, deals with rational numbers. Rational numbers, excuse me, are basically just fractions, okay? I'm going to check one more thing, guys. I'm going to make sure that my mic is on, and it is on. Okay. So, we all probably remember some of these ideas because, we've seen them for a long time. But when you're adding fractions, y'all, or subtracting fractions, the one thing that we absolutely have to have is a common denominator, okay? And this is like, I'm just going to kind of do this on the side note. So I'm going to write it over here. This is like a little side note. Okay. When we're adding or subtracting fractions, we have to have a common denominator, okay? So what I mean by that, y'all, is if I have a pizza here, and we use a lot of times in math for fractions, we use pizzas as our examples because it just makes it a little bit easier. Okay, and I'm going to do the same thing over here. And these pizzas are supposed to be of equal size. Okay, so I'm going to use kind of a purple color. So I have 1, 2, and I have 1 over here. Okay, so y'all, if I were to think about a part of a whole, okay, so if I look at this pizza, this first pizza here, we cut it up into 1, 2, 3, 4, 5, 6, 7, 8 pieces. And out of the 8 pieces, we still have 2 pizzas left, or 2 pieces left, okay? Same thing over here. I've cut this one into 1, 2, 3, 4, 5, 6, 7, 8, and we have 1 piece left, okay? So if we were, end of the evening, it's Friday night, we've already watched our movie, we've already eaten our pizza, we're gonna put the pizza in the fridge, and we wanna put them in the same box. Because these pieces are cut up into equal pieces and they're both cut up into pieces of 8, we can say, look, let's take this piece right here and let's put it in this box. And so in essence, we're adding those fractions together. And so we have 3 out of the 8. Now, in order for me able to do that, y'all, those pieces have to be of the same size, okay? So that's what we mean by a common denominator. They all have to be the same size in order for it to fit nice and pretty, right? So I'm assuming that those pizzas are both the same size. But the question happens, well, what happens when my denominators aren't the same? Well, that's what we're going to figure out how to do over here. Okay. So, y'all, for this problem here has 6 parts. So it's going to take me a little while to go through each of them, but I'm going to really try to take my time with each part to make sure that we're doing okay with this. All right. So look, part A says we're going to add these 2 fractions together, -1/2 plus 2 over 5, okay? So, y'all, in order for me to get my common denominator, what I'm really looking for here is the common multiple between 2 and 5, okay? And again, I'm going to pull something up here, y'all. I'm going to go back to my Blackboard page real quick because what I want to do is I want to get my multiplication table going, okay? And so what I'm going to do here, y'all, and again, like I said, if you're teaching 3rd grade or 4th grade, this is definitely going to be a good approach to do this. Since I'm trying to find the common multiple between 2 and 5, what I'm going to do is I'm going to look at my 2's going down. I'm going to look at my 5's going down, or you can do it going across, okay? And what I'm looking for is what's the first number that they both have in common, and they both have the number 10 in common, okay? So what we're going to do now, y'all, is we're going to write 2 new fractions with my denominator being a 10, okay? And we did a little bit of this on Monday afternoon or Monday afternoon. We said, look, if that's a 2 and I'm getting a 10, I'm really multiplying the bottom by 5. So I also have to multiply the top number by 5. So 2 times 5 gives me that 10. -1 times 5 gives me a -5, okay? And then I'm going to do the same thing over here. I'm going to say, look, what did I multiply 5 by to get 10? Oh, we multiplied that by 2. So I'm also going to multiply the top number by 2. That's going to give me a 4, and we still have a plus in the middle, okay? Now, what I'm going to do here, y'all, is my denominator stays the same, and I'm going to go ahead and add my numbers on top, right? So remember, I think about a negative number is how much money I owe, and a positive number is how much money I have. So if I owe you $5, but I only give you 4, I'm still going to owe you 1. Okay. And there's my answer. Okay. So I'm going to play this game every single time, y'all. I'm going to find my common denominator. And again, a really great way to do this is by using that multiplication table because it's visual, right? I can see exactly what's going on, all right? So look, let's try the next one. We're going to go really slow here. And again, y'all, at any point in time, y'all have any questions, please tell me, and I'm more than happy to help. Okay. Okay, so look, here's my second problem. 13 over 15 minus 3 over 5. Again, the first thing I'm going to do, y'all, I'm going to look at the two denominators that I have, and I'm going to come back and I'm going to look at my multiplication table. Okay, so here's my multiplication table. I'm looking at my number 5, and I'm going to go all the way over here. I'm looking at my number 15. And I want to know from the 5 and the 15, what's the first number that they both have in common? And it looks like 15 is the number, right? So look, I'm going to write two new fractions with the bottom part being 15. Okay. So what I might do here is I might say, look, what did I have to multiply 15 to get 15? Oh, we had to multiply it by 1. So we're going to multiply that by a 1. That's still going to be a 13. Okay. And then I'm going to play the same game. What did I have to multiply 5 by to get 15? Oh, we had to multiply that by 3. So I'm going to multiply that by 3. That's going to give me a 9. And then I'm just going to go ahead and subtract. 13 minus 9 is going to leave me with 4 all over 15, right? Okay, now we do have a part C. So let me look at part C. 7 over 6x plus negative 4 over 3y. Okay, so I'm going to do the same thing here, y'all. 7 over 6x plus negative 4 over 3y. All right, so we're going to do the same thing here, y'all. I'm going to come back. I know that we got some x's and some y's here, but let me just look at the numbers first. I'm going to look at 6 and 3. So again, I'm going to come back to my multiplication table. Here's the number 6, and here's the number 3. And I'm going to go down, and I want to see what's the first number that they both have in common? 6, right? Okay, so that's going to be my lowest common denominator. I'm going to have a 6. Now, because I have those letters, whatever letters I have to also be part of my denominator. So I have 2 letters. So not only do I need a 6, but I need a 6, an x, and a y. Okay? Because this one has an x and that one has a y. I need them both. Okay? So look, y'all, we're going to play a little game here. I'm going to do a little stare and compare. I'm going to look at this piece here, and I'm going to look at this piece here. Now, I already had the number 7, so I'm going to put that 7 up there. But I'm going to ask you a question. What do I have down here that I didn't have the first time? Anybody know? What do I have right here that I didn't have the first time? Didn't we have a y? We have a y here that we didn't have before, so I'm going to have to put that y on the top. Okay, if I put it on the bottom, I also got to put it on the top, right? Because again, y'all, look, y'all, I have the y here, but I didn't have it there. So if I put it on the bottom, I got to do the same thing on the top. Okay. Now we're going to come back over here. I'm going to look at this first part, 3, and now I have a 6. Oh, you know what? We multiplied that by 2. So let's multiply this by 2. So negative 4 times 2, that's a negative 8. Okay. Now, the other thing is, what do I have here that I didn't have before? Oh, the x. So I got to put the x on the top as well. Okay. Now that my numbers on the bottom are exactly the same, 6xy, I'm just going to write the top as one solid fraction. A 7y minus an 8x. Y'all, I cannot combine those pieces because they are not like terms. So I'm just going to stop at that point. Okay. Again, y'all, one thing I want to mention about problems like this here, right? Are you going to do this in 3rd grade or 4th grade? No. If you end up teaching like a 7th grade or an 8th grade class, you might end up doing these kinds of problems with them, right? And this is why I'm going through this stuff, because again, I think when I've asked everybody really wants to teach like the younger kids, but this class really is supposed to prepare you in case you end up teaching like a 7th or 8th grade class. And that's why I'm kind of going through this stuff here, okay? All right, so look, we got another 3 parts just for the first question, okay? Again, I'm going to try to go really slow here, y'all, just to make sure that we're doing okay. So look, let's take a look at part D. I'm going to kind of clean up my pizza pies over here because I don't need them right now. So I'm just going to kind of get rid of that, but I think we all got the idea when we did it. Okay, so let's see. Part D has a -7, 3x squared y squared, plus a 5, 3x y squared, plus a 2x squared y. Okay. Now, y'all, again, I know you've had college algebra, so like ideally you're supposed to know this, but again, it's not so much that you know how to know it, it's how would you teach this to, say, somebody who's in 8th grade? And so, guys, this is, if I was teaching, if I had a group of 8th graders, this would be my approach, okay? And I think that's sort of the idea behind this class is not so much do you know how to do it, ideally you should, but how would you explain this to a group of 8th graders, okay? So look, I'm going to leave my numbers on the top alone, -7, 5, and 2, to break down my bottom numbers. So 3x squared y squared. Remember, x squared means that there's just 2 of them, and y squared means that there's 2 of them, okay? 3xy squared means there's a 3, there's 1x, and there's 2 y's. And then an x squared y means that there's 2 x's and 1 y, okay? And again, I'm really trying to go really, really slow here, y'all, because I want us to get the idea. Okay, for me to find my common denominator, again, would be my approach if I was teaching a bunch of 8th graders. For me to get my common denominator, every number or letter that I see, I'm going to need. And the question is, how many of them do I need? Okay, so I'm going to say, look, I have 1 3 here and I have 1 3 here, but I don't have any there. But in each single piece, the most number of 3s I had, y'all, was just 1. So they all need a 3, okay? And when you might say, well, look, there's 2 3s. Yeah, but in that piece, there's only 1 3, and in that piece, there's only 1 3. That's what I mean by I only need 1 3, okay? I'm going to do the same thing with the x's. I have 2 x's there, I have 1, I have 2 there. So the most number of x's in any of those parts were 2 of them, okay? So I'm going to come back and I'm going to put 2 x's all the way across. And I'm going to do the same thing for my y's. I'm going to say, look, there's 2 y's there, there's 2 y's there, there's 1 there. So the most number of y's I had was 2, so I'm going to put 2 y's all the way across, okay? Now, y'all, I'm going to start working with the top parts, okay? And we're going to do a little stare and compare, okay? Again, this is how I would approach this with 7th graders, 8th graders, whatever it happens to be, okay? So I'm going to do a little stare and compare. Did we change this here at all? No, right? It's exactly the same. So if we didn't change the bottom, I'm not going to change the top, okay? Now, I'm going to do the same thing here. What do I have here that I didn't have before? And you might say, oh, look, you put an extra X. Well, if we put an extra 1 on the bottom, we got to put 1 on the top, okay? And then I'm going to do the same thing here. What do I have here that I didn't have before? Well, I have a 3 and I have a Y, okay? So now, y'all, we're going to go really slow. Look, 3xxy is the same thing as 3x squared y squared, okay? And I'm just going to write a single fraction. I'm going to write my -7. I'm going to write my positive 5x. And when I multiply that together, 2 times 3 is going to give me a 6 with a y. And that's where we're going to stop, okay? Again, if I was dealing with 8th graders, this would be my approach because I'm really trying to break it down so that they can visually see what's happening here, right? And we can do that kind of thing like, what do I have now that I didn't have the first time? And I think when you're dealing with that age group, right, the 7th or 8th graders, because they're going to start doing a little bit of pre-algebra, this is a good way to approach it, okay? Okay, so look, let's take a look. We got 2 more parts. Let's take a look at part E. And let's take a look at part F, okay? So, I don't know, part E. I'll tell you what, let's do something real quick, y'all. I'm gonna come back and do parts E and F in like 10 minutes, okay? Maybe not even that long. Let's come back to it because what I wanna show you is the next part right here. I want to do these two and these two problems, and then we'll come back and do parts E and F. So what we're doing here, y'all, we're going to change our improper fractions to mixed numbers. So in case you forgot, what is an improper fraction? An improper fraction just says the number on the top, y'all, is going to be bigger than the number on the bottom. So we noticed here 58, yeah, it's a lot bigger than 3. Okay, so how do we do this? We're going to divide the denominator into the numerator. So we're going to divide the bottom number into the top one. The quotient is the whole number part of the mixed number, and the remainder is going to be the numerator of the fraction. Okay, so let me go through the first problem to kind of walk you through it. And again, you might remember this, right? 58 divided by 3. Okay, so 3 goes into 5 one time. Subtract. 5 minus 3 is 2. Bring down the 8. Okay, and 3 would go into 28, I would say 9 times. That's a 27. And my remainder is a 1. So what I'm going to do now, y'all, we're going to write this as a mixed number. This number here is the whole number part. We write like a really big 19. The 1 is the numerator, and the 3 is what we have on the bottom, and that's how we write our mixed number, okay? Now, when we look at part B, I know there's a negative there. Don't worry about the negative right now, okay? We'll worry about the negative in a little bit. We're going to do the same thing. We're going to say, what's 391 divided by 100? Well, 100 goes into 391 3 times because that's going to give me a 300. And when I subtract, that's going to give me a 91. Okay. So again, this is my whole number part, right? I'm going to write a really big 3. My remainder is always the number that goes on top, and whatever I was dividing by goes to the bottom. And you might say, okay, what about that negative? Boom. There it is. Okay. Now, let me jump to the next two problems, and then again, we'll come back to problem number 1, and we'll finish parts E and F, okay? So look, let's come back over here, and now we're going to go backwards. We're going to change a mixed number to an improper fraction. So how do we do this? We're going to multiply the whole number by the denominator. We're going to add the numerator, and that's going to give me my new numerator, and my denominator is not going to change. Okay, so let's go through it slowly. Multiply the whole number by the denominator. So we're going to multiply like this. 9 times 2 is 18. Okay, then I'm going to add the number on the top. 18 plus 8, that's going to give me a 26. And the number on the bottom stays as a 9. Okay, I'm going to do part B. I'm going to do it exactly the same way. Don't worry about the negative right now, y'all. Okay, so look, let's just go like this. 1 and 5 sevenths. We're going to multiply. 7 times 1 is 7. We're going to add the number on top, plus 5. That's going to give me a 12. The number on the bottom stays exactly the same. Okay. Now, a couple of things, y'all. We've got our two answers, right? And if you wanted to check to see if you did that right, we could just go backwards, right? We could say, look, how many times does 9 go into 26? Goes in 2 times. We subtract, that's 8. So that would be 2 and 8 over 9. And that's exactly what we started off with, right? So again, that can be a way that you're going to check. Oh, I forgot my negative over here because it was a negative. But that would basically be the way I could check, right? So these two problems, like the second and the third problem we did, y'all, we're just kind of going back and forth, okay? Now, the reason I wanted to do those two problems first is in order for me to come back and do parts E and F. If I look at parts E and F, if you notice, we have mixed numbers, right? So again, there's a couple of ways I can go about doing this, y'all. So let me do part E. It's 7/10 minus 3 1/8, okay? So part E, 7/10 minus 3 1/8. Okay, so guys, my approach, if I was doing this, I would say, look, let's convert this guy to an improper fraction. Let's leave that as 7/10 minus. Okay, now I'm going to multiply. 8 times 3 is 24, plus 1 more is 25. Okay, so now I have 7/10 minus 25/8. Okay, I need to find my common denominator. So y'all, I'm going to go back to my multiplication table, okay? Oops. come back to my multiplication table. I'm looking at the numbers 8 and I'm looking at 10. And I want to see what's the first number that they both have in common. And it looks like 40 is the first number that they both have in common, right? So what I would say is, look, let's write two new fractions with the denominator being 40, okay? And I would say, what did I have to multiply 10 by to get 4? I'm sorry, to get 40, I'd have to multiply by 4. Oops. So 4 times 10 is 40. 4 times 7 is 28, okay? And I might say, what do I have to multiply 8 by to get 40? Oh, I got to multiply it by 5, okay? So 5 times 25, like if I had 5 quarters, y'all, I'd have $1.25, right? Okay, now this is what I'm going to do next. My bottom number is going to stay at 40, okay? 28 minus 125. Remember, I'm taking a small number and I'm taking away a bigger number, so I know my answer is going to be negative, right? Like if I owe you $125 and I only pay you 28, right? Again, y'all, the way you can do this, just go 125 minus 28, right? But we're going to keep it negative. So I'm going to borrow one from here. 15 minus 8 is 7. Let's see, 11 minus 2 is 9. So that's a negative 97 over 40. Okay. Now, y'all, if this here is an improper fraction, right? If I wanted to convert that to a mixed number, remember what we would do? We'd say, look, how many times does 40 go into 97? 2 times, that's 80. When I subtract, my remainder is 17. So I can think about this also as a negative 2 and 17 over 40, right? Again, I'm showing you the two answers, y'all, because I'm not certain if my lab is going to let you do an improper fraction. If it does, leave it as negative 97 over 40, right? But if it doesn't, you can write it as a mixed number. Okay. So look, we still got part F. Let's do part F, and then we'll continue on with what we got. Okay, part F is negative 4.5 plus 1 1/4. Okay, negative 4.5 plus 1 1/4. Part F, negative 4.5 plus 1 1/4. Okay, 1 1/4. Okay, y'all, I would probably do the same thing here. I would say, look, let me convert these things to improper fractions. So remember, we're going to multiply. 2 times 4 is 8, plus 1 more is 9. That's a negative 9 over 2. 4 times 1 is 4, plus 1 more is 5. And that's negative 5 over 4. So again, y'all, my approach would say, okay, I need to find a common denominator. Okay, so between 2 and 4, I'm going to come back to my table. Look, here's 2, here's 4. The first number we have in common is 4, y'all. So I'm going to write this as a 4 here and a 4 here. And I'm going to say, what did I multiply 2 by to get 4? I multiplied it by 2. So that's a minus 18. What did I multiply 4 by to get 4? We just multiplied it by 1. So that still stays as a 5. Okay. And negative 18 plus 5 is going to be a negative 13 over 4. And again, if I needed to convert it, y'all, I would just say, look, what's 13 divided by 4? Well, that goes in 3 times with a 12 with a remainder of 1. So as a mixed number, that would be a negative 3 1/4. Okay. So again, y'all, I don't remember when I started doing negative numbers in school. I want to say it was maybe like 5th grade or something like that. It could have been 6th grade. So again, if you end up teaching like, 1st, 2nd, 3rd, 4th, yeah, you're going to have fractions. You're going to have negatives, no. But again, I don't know, where you're going to end up with. So that's the point of going through this stuff here, okay? All right, so look, we finally finished problem 1. We did 2, we did 3. Here we go. Okay, so y'all, for this problem, they give me a table and they tell me the team, how many games they played and how many games they won. Okay, and there's 3 questions to this problem. And it says, the first question says, which team won more than half the games and was closest to winning half? Okay, so they got to win more than half, but they're really close to winning half. The second question says, which team won less than half of its games? And it's closest to winning half. And the third question says, which team won more than a third of its games and was closest to winning 1/3? Okay, so y'all, this is how I would approach it. If we're talking about which team won more than half of the games, the way I would approach this, y'all, is I would do this. Look, let's multiply each of those numbers by 2, okay? Why by 2? Because if you won half the games, then the number of games you won, if you doubled it, should be roughly about how many games that you played, okay? So look, 10 times 2, that's 20 games. 10 times 2, that's 20 games. If I do this one times 2, that's 18, right? And I could kind of keep playing the same game, and I would probably do that for every one of them. Okay, so 16, 14, 12, and 10. Okay, what I'm trying to figure out here, y'all, is if I'm trying to figure out which team won more than half of the games, okay? So if I want to find which team won more than half of the games, what I'm trying to do here is once I multiply those numbers by 2, which one of those teams here, once I multiply the numbers by 2, was bigger than the number of games that they played? So if I look at, say, the first one, say the Vipers, when I multiplied it by 2, I got 20, but that's not bigger than the number of games that they actually played. But when I multiply the Dolphins by 2, I get 20, and that's actually more than the games that they played. So they won more than half of the games, and they're really close to that number. So the first one here, I would say, look, this is going to be the Dolphins, okay? Now, which team won actually less than half of the games? So looking at those same numbers, I want to make sure that this number here is slightly smaller than those numbers. Well, it looks like the Vipers, right? That's 20. It's slightly smaller than 22. So the Vipers would be the team that won actually less than half of the games, but it's almost half, okay? Now, for the last part, y'all, it says, which team won more than a third of the games? Okay, so look, I'm going to come back here, and I'm going to do the same thing, but I'm going to multiply the numbers by 3. Now, guys, we already did the Vipers, and we already did the Dolphins. So I know that those guys aren't going to be the third because we already found out that they were the halves, right? So let me multiply these numbers here by 3 and see which one is close, which one is more than a third and closest to winning 1/3. So look, 9 times 3 is 27, 8 times 3 is 24, 7 times 3 is 21, that's 18, and that's 15. Okay, again, y'all, I'm going to do a little stare and compare. I'm looking for the number here that's slightly bigger than the one over here. And it looks like the Hawks, because 24 is slightly bigger than 22, so they won more, and it's about 1/3, right? How do I know it's about 1/3? Because when I multiply this number by 3, it's close to that number, but this number has to be bigger in order for it to be more than, okay? So again, here I would say this is the Hawks, right? And like 21, it's smaller than 27, so that's not more. 18 is smaller than 26, okay, that's not more. 15 is smaller than 23, okay, that's not more. And that would be my approach and how I would go through something like this, okay? Okay, now, for this problem here, y'all, I was going through this problem and I was trying to figure out the easiest way to explain this. And I think the easiest way that I would probably explain this problem here is it says approximate each of the following fractions as either 0, 1/4, 1/2, 3/4, or 1. And then tell whether our estimate is either high or low, okay? So guys, the way I would probably approach something like this is I would probably convert these numbers to decimals, okay? So 0 as a decimal is still 0. And if you're wondering, what is 1/4 as a decimal? I would go, look, what's 1 divided by 4? 0.25, okay? So 0.25. 1/2 is a decimal. I think we know that one already because we've done it before. 0.5, right? 3/4, think about it in terms of money, 75 cents, and 1 is still 1, okay? So now this is what I'm gonna do, y'all. I'm gonna take those fractions and I'm just gonna divide them out, okay? So the first fraction I have is 23, oops, let me move this over. Okay, 23 divided by 47. So look, 23 divided by 47, I'm coming up with 0.489. Okay, my question to you, that number, 0.4893, I know there's a bunch of numbers there. That number is closest to what? 0, 0.25, 0.5, 0.75, or 1? 0.48, it's really close to 0.5, right? And 0.5 is the same thing as 1/2. So right here, y'all, I'm gonna say, look, this is about 1/2, okay? Now, it's gonna ask me, is that estimate, is it either high or is it low? Now, remember guys, 1/2 is 0.5. Is 0.5 smaller, or is it, I'm sorry, is 0.5 higher or lower than 0.48? Well, it's higher, right? So right here, y'all, this is gonna be a little drop-down menu. I'm gonna say my estimate is high, okay? Now look, let's do the same thing with 3 over 167. So 3 divided by 167, okay, 0.017 and so on and so forth. Okay, what number is that really close to? Oh, it's really close to 0, right? Again, my estimate here, y'all, is high. Why? Because this number here is higher than 0 itself, okay? Now, let's do part C. 150 divided by 201. 0.746. 0.746 is really close to 0.75, which is 3/4, okay? And then I'm going to ask you, is 0.746, is that higher or lower than 0.75? Oh, it's lower. So my estimate here is going to be low. Okay? And then I'm going to do the last one. What's 16 divided by 17? 0.94, okay, that's really close to 1. Okay, and again, my estimate is low, and you might say, why is it low? Because this number here is smaller than the number 1, okay? And I think that's probably the easiest way I would go through a problem like this. I would convert them to decimals because it's easier to compare some of those numbers there, all right? Okay, so let me keep scrolling along here. Let's see what else we got. Okay, so it says, look, the following ruler contains segments marked MATH. It says, use mental mathematics and estimation to determine which segment contains the fraction 16 over 6. Okay, so look, y'all, 16 over 6. If I was thinking about converting this, say, to a mixed number, does anybody know how many times 6 might roughly go into 16? What do you think? 6 goes into 16 about how many times? If I were to look at my multiplication table, y'all, here's 6. The first number closest to 16 without going over it is actually a 2, right? So it's going to go 2 times. That's a 12. My remainder is a 4. So it's going to be a little bit more than 2. So if here's 2 and if I'm a little bit more than 2, what section am I going to be in? I'm going to be in section A, right? Okay, so y'all, the next part here says a class consists of 1/4 freshmen, 1/8 sophomores, and 3/8 juniors. The rest are seniors. What fraction of the class is seniors? Okay, so y'all, what I'm going to do here, I'm going to take these fractions and I'm going to add them together. So look, 1 over 4 plus 1 over 8 plus 3 over 8, okay? Now remember, the next thing I need to do, y'all, I need to find my common denominator. So I'm looking at the two numbers 4 and 8, okay? Again, I'm going to come back to my multiplication table. Here's 4 and here's 8, and you can see the first number that I have in common, y'all, is 8. So I'm going to come back over here, I'm going to put an 8, an 8, and an 8. I'm going to say, look, we multiplied that guy by 2, so we got to do that one by 2. We multiplied this one by 1, so we're going to do that one by 1. And we multiplied this one by 1. Okay. Okay, so now we're going to just add straight across. Remember, my denominator doesn't change, stays 8. So 2 over 8 plus 1 over 8 plus 3 over 8. 2 and 1 is 3, and another 3 is 6. Okay, so we have 6 over 8. Okay, now this is how many are, this is the fraction of the class that are freshmen, sophomores, and juniors all combined. Now it says, what fraction of the class is seniors? So y'all, when I think about the whole class, I'm going to try to draw a picture here, okay? And I'm going to cut this picture up into 8 pieces. Why 8 pieces? Because that's exactly what I have there, okay? And I want you to think about this. Look, 1, 2, 3, 4, 5, and 6. If that red part there represents the freshmen, the sophomores, and the juniors, wouldn't this piece over here have to be the seniors? And so what would I have left? How many pieces do we have? We have 2 out of the 8, which I can reduce to 1/4. Now, I want to show you basically what it is I'm doing to get that. And again, I drew the picture because I think a lot of us are visual learners. But what I would do is I would say, look, remember, think about this as one whole pizza pie, right? So if I were to think of the number 1, and I'm going to take away everybody else, 6 over 8. The first thing I would do is I would say, look, let me think about that as 1 over 1. And between 1 and 8, what's my common denominator? Oops. What's my common denominator? Look, here's 1 and here's 8. And the first number they have in common is 8. So I would say, look, let's put an 8 here. That's still a 6. I had to multiply this by an 8, so I got to do that by an 8. And if I subtract now, 8 minus 6 gives me 2, which is exactly what we had there, and then we just reduce the fraction. This here shows the actual steps on how I did it, but the picture gives me that visual, right? I know I had 6 out of the 8, so the rest of it has to be the seniors. And the rest of it is 2 out of 8, which reduces to 1/4, okay? All right. So we still got a few more problems to do, so let's see if we can knock these out. Okay, and it says a clerk sold 3 pieces of one type of ribbon to different customers. One piece was 5 7/8 yards long. Another piece was 7 6/7 yards long, and the other one was 16 and how much? 1/4. Okay. What's the total length? So y'all, if we're looking for the total, we're just going to add those numbers together. Okay. So look, let's do the easy breezy CoverGirl part first. Let's add 5 and 7 and 16. Okay. So for this, y'all, I'm just going to go 5 plus 7 plus 16. Okay, so far I got 28. Okay. Now, I still need to add those fractions, though. So look, 7/8 plus 6 over 7 plus 1 over 4. Okay. So, y'all, just like we've been doing before, I'm going to find my common denominator. Okay. But now I'm going to look at 8, I'm going to look at 7, I'm going to look at 4. So I'm going to come back to my multiplication table. Okay. 7, 8, and 4. I want to find the first number that they all have in common between 4, 7, and 8. So 7 and 8 have, their first one is 56, right? But that's also in 4. So it looks like the number that they all 3 have in common, the first one is going to give me 56. Okay. So right here, y'all, I'm going to put a 56, a 56, and a 56. Okay. And again, I would say, what did I have to multiply 8 by to get 56? I had to multiply by 7. So that gives me a 49. Okay. I had to multiply this guy by 8. So that gives me a 48. And 14, what do we have to multiply 14 by? I'm sorry, 4 by 14, right? Oops. Kind of gave it away there. By 14, so that's a 14 right there. Okay. Now, let's go ahead and add. So 49, 48, and 14. Let's see. 49 plus 48 plus 14 is 111. Let me just double check. 49 plus 48 plus 14. Yep, 111. Okay, 111 over 56. Now, again, y'all, this thing right here is an improper fraction. I want to change it to a mixed number, okay? So look, we're going to take 56 and we're going to divide it into 111. Okay, so 56, oops, into 111, not 112 over. Okay, so look, let's try this. What's 56 times 2? Ooh, that's too much, 112. So I got to do this one time, 56. And if I subtract, what's 111 minus 56? Ooh, that's 55. Okay, so this part right here, y'all, as a mixed number is 1 and 55 over 56. So if I'm adding 28 and 1 and 55, 56, that's going to be 29 and 55 over 56, okay? Okay, so look, we still got a little bit more left to do. Let's try this next one here. It says, from a 20-foot roll of rubber hose, a person cuts lengths of 5 3/8, 5 1/2, 4 1/4. How much is left? Okay, so let's do this. Let's add those numbers together. Again, y'all, I'm going to do the easy breezy cover girl part first. Let me add those numbers. 5 and 5 is 10, and another 4 is 14. Okay, let's add 3 over 8, and 1 over 2, and 1 over 4. Okay, so my common denominator here again, y'all, and again, you know, I'm pulling up my multiplication table every single time. I'm not saying necessarily that you need to do this, but again, when you're doing this with your class, right, whether you're teaching 4th graders or 5th graders, I would definitely, if I was an elementary school teacher, I would definitely have a big multiplication table up on somewhere in my room so that my students could see this, right? So if I'm looking at 2, 4, and 8, it looks like 8 is the first number that they all have in common. So that's an 8, that's an 8, that's an 8. Okay. So we multiplied this guy by 1. So that stays a 3. We multiplied this one by 4. So that's a 4. And we multiplied this one here by 2. So that's a 2. Okay. So now I'm going to add together. 3 and 4 is 7. And another 2 is 9. Okay. 9 over 8. Now, I want to go ahead and convert that to a mixed number, right? So look, we're going to take 8, we're going to divide it by 9, goes in one time, with the remainder of 1. So this is 1 and 1/8. Okay. Again, y'all, I'm going to go ahead and add those two numbers together. So we used 15 and 1/8 feet of that rubber hose. Okay. Now remember, the question was really asking me how much was left. Okay. It's kind of a longer problem, all right? So look, we had 20 feet and we used 15 and 1/8. So look, y'all, I'm going to convert this 15 and 1/8 back to a improper fraction. So 8 times 15, let's see. 15 times 8 is 120. We got to add 1 to it, 121. So this is 121 over 8. Okay. Now we have 20. I'm going to think of 20 as a fraction. I'm going to write it as 20 over 1. Okay. My common denominator here, y'all, is still going to be 8. Okay. So look, I'm multiplying this guy by 8. I'm multiplying that guy by 8. That's 160. I'm multiplying this one by 1 and that one by 1. So that's 121. And 160 minus 121 should be something like 39 over 8. This is my answer as an improper fraction. If they do ask you to write it as a mixed number, remember, you're just dividing. That goes in 32 times with a remainder of 7, which is 4 and 7 over 8. Okay. Again, you know, I'll put it this way, y'all. In all my college classes, improper fractions are perfectly fine. But I do remember elementary school, everything was a mixed number, right? Because it's kind of easier to understand that idea of a mixed number, okay? All right. So I'm just going to kind of scroll on. I'm just curious to see what we still got left. 1, 2. 3 for, I think we got, yeah, we got about 4 problems left, but this one has a few parts. Okay, so y'all, one thing I want to emphasize about this problem here, I've been using my multiplication table to find my lowest common denominator, okay? But finding the lowest common denominator just means that I usually don't have to reduce my fractions too much, but we can also find other denominators that are still common, they're just not the smallest ones. And that's sort of the approach that they do in this problem. So I want you to notice the directions on this problem. It says, check that the following is true, that 1/3 is equal to 1/4 plus 1/3 times 4. And they kind of walk you through the problem here. And it says, look, start by simplifying 1/3 times 4. Okay, well, look, 1/3 times 4, that there, y'all, would just give me 1/12, okay? Because 3 times 4 is 12. Now it says, the second part says, write each fraction with a common denominator and add. So y'all, what they're doing here, instead of coming back to the multiplication table and saying, look, let's look at 4 and let's look at 12 and let's find the first number that they have in common, they're not finding the lowest common denominator, but they are finding a common denominator. What they're doing here, y'all, between the 1/4 and the 1/12, they're going to do this. Look, what's 4 times 12? That's going to give me 48, okay? That's still going to be, it's not going to be the smallest common denominator, but it is going to be a common denominator, okay? And so now the next thing I'm going to do here, y'all, is I'm going to say, look, what did I multiply 4 by to get 48? Oh, we multiplied it by 12. So I'm going to multiply that one by 12 too. Okay. And what did I multiply 12 by to get 48? Oh, I multiplied it by 4. So I'm going to multiply that one by 4 too. And now that my denominators are the same, we can add the numbers on the top. 16/48, okay? So when I do this, y'all, I notice that I'm getting that answer right there. And that's the answer that I really want to get, okay? Now, we're going to just reduce this fraction, okay? So if we're going to reduce this fraction, y'all, 16 and 48, one thing I always tell my students is when you're going to break down a fraction, look, they're both even. Let's divide them by 2, okay? Half of 16 is 8. Half of 48 is 24, okay? Let's divide them by 2 again, because I can keep playing that game. Half of 8 is 4, half of 24 is 12, okay? And look, let's do it again. Half of 4 is 2, half of 12 is 6. And let's divide it by 2 again. Half of 2 is 1, and half of 6 is 3. So I end up with a 1/3, which is what we're going to write right here. And that's what we're looking for, okay? Okay, so look, y'all, for the second part, I'm going to do the same process. Look what it says. The directions even say, follow a similar process to verify 1/4 is the same thing as 1/5 plus 1/4 times 5. Okay, so look, without looking at my choices here, y'all, I'm going to do this. I'm going to say, look, I have my 1/5 here. This here is going to give me a 1/20, okay? Because 4 times 5 is 20, okay? Again, I'm going to do the same kind of idea here, okay? I'm going to go through and say, look, I'm just going to multiply those two together. That's 100, and that's 100, okay? What did I multiply this by, guy? By 20, so that's 20. Multiply this one by 5, so that's a 5, okay? And I'm adding together, and that's going to give me a 25/100, okay? And I'm going to look at my choices here. Look, I got A, B, C. Okay, there was just 3 choices, A, B, and C. And so I'm going to look at what I have right here, and I'm going to say, okay, look, do I have that anywhere? Oh, yeah, I do. Look, we got it right there. And if we were to think about this, and I'm going to go big here, y'all, I'm going to divide them both by 25. 25 goes into 25 once, and 25 goes into 104 times. So my choice here would be C. Okay. All right. So got one more like this, and then again, we'll go on to the next part. Process, y'all, going to be exactly the same way. Look, I'm going to write 1/6 plus 5 times 6 is 30. Okay. I'm going to play the same game. I'm going to multiply those two numbers together. That's a 180. Okay. We multiplied this guy by 30, so we're going to do that one by 30. There's a 30 up there. We multiplied this one by 6, so we're going to multiply that one by 6. That's a 6 up there. When I add them together, that's a 36 over 180. I'm going to look at this, and I'm going to look at my choices that I have, and it looks like choice B gives me that 36 over 180. So there's my answer. Okay. All right, guys, I'm going to come back and do this solve for x1 in a minute. I want to do these next two problems first, and then we'll come back and do that one over there, okay? So looking at this problem here, y'all, it says one recipe calls for 1.5 cups of milk, and a second one calls for 2 3/4 cups of milk. If we only have 4 cups of milk, can we make both recipes? Okay, y'all, so obviously this is a pretty simple in the sense that it's either yes or no, right? So you got a 50-50 chance of guessing it, right? But what I would tell you is to do it this way. If I was approaching this problem, I would say, look, I want to add those two numbers together, and I got to make sure that if I want to make them both, it has to be under 4 cups, right? Or 4 cups or less, because that's all the milk that I got. So what I would do is I'd say, look, how do I write this as an improper fraction? 2 times 1 is 2, plus 1 more is 3, okay? 4 times 2 is 8, plus 3 more is 11. And I would say, okay, what's my common denominator here? I would come back to my chart. I would say between 2 and 4. Again, 4 is my common denominator. So we multiply that one by 2. So that's a 6. We multiply that one by 1. So that's still an 11. Okay, and if I add them together, 11 and 6 is going to give me something like 17 over 4. And then what I would do is I'd say, look, let me convert that back to a mixed number. So 4 into 17 goes in 4 times with a remainder of 1. So this is 4 and 1/4. So when I put those two together, I need 4 and 1/4 cups of milk. But I only have 4 cups of milk. So can I make it? No, because we need more than 4 cups, right? Because we need 4 1/4 cups. Okay. Okay, so again, y'all, let me do this one here, and then I'll come back and look at the one that I skipped. I'll come back and do that one in a second. So look, y'all, it says 2 fractions have a sum of 1. If one of the fractions is a over b, what's the other one? Okay, so this is how I'm going to think about it, y'all. When I take my fraction, a over b, and I add it to something, I'm going to get 1, okay? I'm putting a question mark there, y'all, because I don't know what I have to add it to. So if I wanted to figure out what this number is here, I could say, look, let me subtract my a over b over here, okay? So whatever I have is going to be 1 minus a over b, okay? I know this is kind of more abstract, y'all, because I don't really have numbers here. I want to think of this one as 1 over 1 minus a over b, okay? So y'all, in order for me to get a common denominator, I don't know what my number b is, but I know I can think of 1 over 1 as b over b, okay? Because any number divided by itself other than 0 is going to give me 1. And so now I have a common denominator. So I have b minus a all over b, and I'm going to look at my answer choices that I have, and that looks like choice D. D as in dog. And there's my answer, okay? All right, so let me scroll back, y'all, to that other problem that I had skipped over. This one over here, okay? And again, this is more solving an equation. So again, y'all, this is probably going to be something for more like maybe 5th or 6th, 7th grade, something like that, okay? So look, again, I'm going to walk you through the process. X plus 2 1/3 is equal to 3 1/5. The first thing I would do, y'all, I would probably convert these numbers, again, to improper fractions. So 3 times 2 is 6, plus 1 more is 7. That's a 7/3. 5 times 3 is 15, plus 1 more, 16/5. Okay. And then again, I would subtract 7/3 on both sides so that I can get my x by itself. Now, first thing I'm going to do here, y'all, I'm going to look at my two denominators, okay? Between 5 and 3, here's 3, here's 5. The first number that we have in common is 15, okay? So look, there's a 15 there, there's a 15 here. So I'm multiplying this guy by 3, and I'm multiplying that guy by 3. That's a 48. I'm multiplying this one by 5, and I'm multiplying that one by 5. That's a 35, okay? And then I would say, look, what is 48 minus 35? 8 minus 5 is 3. 4 minus 3 is 1. So my answer is 13/15. Okay. And again, all I'm doing here, y'all, converting them to improper fractions and then doing the math behind it. Okay. Okay. So look, let's do part B. Okay. So I'm going to do part B over here. Here's part B. X minus, 2 2/3 equals 5/6. Again, y'all, I'm going to convert this guy here to an improper fraction. So 3 times 2 is 6, plus another 2 is 8. So look, that's 8/3 equals 5/6. Okay. I'm going to add 8/3 to both sides. Let's see, there we go. Okay, let's get rid of those. Okay, I'm going to look at my two denominators, 6 and 3. Again, y'all, and I'm hoping as I'm doing these things, you're like, do we really got to go back to the table every time? I know that you guys know how to do this. It's not so much that, again, this is how you would do this if you were teaching, younger kids. Use the table because it comes in really handy. But again, between 3 and 6, they can see that 6 is their common denominator. And guys, kids are smart. As you start going through these things here, they're going to pick up on that really quickly. Okay. So look, we multiplied this 6 by a 1, so we're going to multiply that 5 by a 1. That's a 5. I multiplied that 3 by a 2, so I'm going to multiply that 8 by a 2. That's a 16. Okay. 5 and 16 is 21/6. Now again, in elementary school, they usually say, hey, let's write the mixed number, right? Okay. So let's take 21 and let's divide it by 6 to go in 3 times. We subtract 21 minus 8 is remainder of 3. So this is going to be 3 and 3/6. But look, y'all, I can reduce that 3/6 to a 1/2. Okay. And there's my answer. Okay. So again, y'all, as you're going through these problems, take your time with them. But again, I think a lot of times with the computations, I think it makes things easier to go to improper fractions and then, kind of do your math from there and then go back and rewrite it as a mixed number. All right. So let me go ahead and stop recording. Let's come back this way. Yes, good. We're recorded.